Welcome. Today's video is about Kyle Adams, a religious flat earther from US who have started something he calls the Flat Earth Institute of Science. I covered him before, and this so-called professor have started a series of videos that he calls Flat Earth Science, and we will look at 2 parts of lesson 1.
This is Flat Earth Science. In the syllabus, we mentioned how good science should be founded on observation, so let's get right to it. What is the greatest evidence for a flat Earth? I don't like dragging things out, so I'm just going to tell you. The greatest evidence is the evidence that first puts the idea or hypothesis into your head that the Earth could be flat. The greatest evidence is the evidence that starts you on your journey. Alright, now to be clear, let's start by defining the word evidence. These definitions are brought to you by dictionary.com. Evidence. That which tends to prove or disprove something. Ground for belief. Proof. Something that makes plain or clear. An indication or sign.
In law, data presented to a court or jury in proof of the facts in issue, and which may include the testimony of witnesses, records, documents, or objects.
So with that being the case, is there any evidence that the Earth is flat? Absolutely. This observation of a flat horizon is a clear sign or indication that the Earth could be flat. Thereby, it qualifies as evidence.
Okay, Kyle, so you're trying to prove that we live on a flat Earth using a dictionary and an image of the horizon. I'm convinced that you already know the answer why you can't see the curve on that image, and it's because that the Earth is so big, so it wouldn't be possible to see the curve on that image. Okay, we move on your video and hear what you have to say.
So here we have evidence number 1. We'll be collecting additional evidence throughout our journey, so we can build a nice, strong foundation. Now, a good hypothesis is founded in observation. So here, this observation of a flat horizon is enough to form a hypothesis that the Earth is flat. We're not talking about mountains, of course. But we are forming the hypothesis that the Earth is not a globe. Alright, so we have made an observation, and we have formed a hypothesis. Next, we need to put our hypothesis to the test. So buckle up. This is going to be quite the adventure.
Kyle, you seem to be a nice and sensible person, but I'm sorry. This will not be an adventure. It sounds like it will be a big dumpster fire. This was part of one of the first lesson. Let's have a look at part 2 of lesson 1. Buckle up, this will be stupid.
In lesson 1, part 1, we looked out at the horizon, observed that it appeared flat, and with that observation, we formed the hypothesis that the Earth is flat. On the other hand, some people have gone out and observed the horizon and have seen curvature. With that observation, using the same reasoning, they are able to form a rivaling hypothesis that the Earth is a globe. Alright, so now that we've got 2 rivals, let's put our hypotheses to the test and see which is stronger.
The fact that the Earth is a globe is well known, and it's easy to observe and can be proven in so many ways. But you will cherry pick one. Is that science? No, it's not.
First, let's go take a closer look at this observation so we can see what we are up against. This observation comes from mctoon.net. mctoon is an anti-flat earther whose entire website is dedicated to combating the flat Earth hypothesis.
And you, Kyle, are anti-globe and anti-science. Seriously, you're lying. What do gods say about lying? mctoon's page is not all about flat Earth. He is a debunker and he debunks flat Earth, 5G, and several other topics, not only flat Earth. He's debunking people who are science denying and spreading conspiracy theories.
He also has a YouTube channel dedicated to the same thing. Just so you know what you're looking at here, the red bars are simply just straight edges. They are meant to be a control in the experiment, representing a standard of flatness. Now, just basing it off of this observation alone, it looks pretty flat. But that isn't what he's basing his globe Earth hypothesis off of. Since the Earth is so big, he doesn't believe we would see much curvature this close to the surface. But he believes that if he scrunches the photo horizontally, it will reveal the hidden curvature of a globe Earth. Alright, here we are back at his website. I'll go ahead and scroll down here. There's his image. There we are a little bit more zoomed in. And this is where he has compressed his image horizontally. And lo and behold, we can see curvature. Here, I'll do the same thing for you so you can see what he did.
And this is the experiment that Kyle cherry-picked. And why did he pick this one? The explanation was in his description. The curvature of the Earth is so hard to see on this type of images. The Earth is too big. And the compression, when you do that, you need a very high resolution image. Kyle will use a low resolution copy of the image that the MC did use. Okay, let's hear more from him.
Alright, this trick is really simple. All you do is select the horizon between the two beams, and then you grab it by the corner and scrunch it really quick. And then we can take a closer look here. Oh my goodness! You can see the curvature of the Earth! Or do we? Let's try this on the other side here.
Okay, select it. Scrunch it. And take a closer look. What? Where's the curve?
Why in the world is it curved on one side, but not curved on the other? I actually went and talked to mctoon about this, and he still thinks the right side is curved. So let's take this to the next level and measure this thing. This time, we are not going to scrunch the photo. We are going to measure the unscrunched photo so there can be no dispute about the scrunching process distorting the photo or the camera being tilted or anything like that.
And here you will get a big problem, Kyle. I don't know if you are dishonest or is it that you lack knowledge about the images, because it's a big difference between when MC does it and when you do it, because MC have the high resolution image and you are using a low resolution image, and then you're starting to pixel counting on the low resolution image. That's not science, dear sir. That's not science.
First, I'm going to sharpen this image by adjusting the brightness and contrast. This will make things easier to count the pixels as we measure the rate at which the horizon appears to curve. Alright, now here you can see I have measured it out to be just over 200 pixels. And here is where we can observe that this portion is all flat within 2 pixels. Let's continue on now, doing the same thing. Just zoom in here.
Alright, now we'll adjust the brightness and contrast. Okay, now here I measured it out. 100 pixels, 200 pixels, 300 pixels. And as we zoom in here, we'll see that it's gone up a pixel. So our rate of curvature is 1 out of 300 pixels. Now we're starting over. 200, 300, but it's still straight, so we'll continue on. 400, 500, oh, now it's moving up. So our new rate of curvature is 1 out of 513. Starting over. 100, 200, 300, 400. And as we see it, it's kind of in the middle of the beam, but it's still straight, so we'll keep going. 600, 700, 800.
915. We're definitely seeing curvature here, but it's curving at an uneven rate. Now, the brightness and contrast got a little messy over here on the right side, so we'll go ahead and readjust that so we can get an accurate measurement. Many globe earthers claim that because curvature was present, that automatically means the curvature was caused by a globe earth, and then that utterly destroys the entire flat earth hypothesis. But if that curvature was being caused by a globe earth, why was it so inconsistent? And why did it appear flat on the right side? It seems both hypotheses have a problem to deal with here. The flat earth has to explain the curvature, and the globe earth has to explain the inconsistency of that curvature and the lack of curvature on the right side here.
It's not so difficult to explain, and I did it before. The poor quality of the image and that the Earth is so big, so at that scale that you're looking on, the curvature is hard to see, and with the poor image quality as you used, it's impossible.
So, what could be causing the appearance of this curvature on a flat Earth? Here's a little something to remember. The moisture content and density of the air is not perfectly uniform. If the atmosphere is thicker on the left than it is on the right, then we won't be able to see as far on the left as we can on the right, and that is going to cause the horizon to appear to curve. In a way, the atmosphere on the horizon can act like a tree line. Here our tree line appears to curve in the grass because those trees on the left are closer to us than those trees down in the middle. Here's a nice condensed example of what I'm talking about. Here we can't see as far on the left as we can on the right. And that's causing a curve down in the grass there where the fog meets the grass. Here, I'll go ahead and draw that in for you. Going across, it goes up, and then it levels out again.
And that explanation have several problems. A very big one is, why is this type of observation repeatable? You get the same type of result every time. If it would be the moisture in the atmosphere and so on, then it wouldn't be the same result every time you do this type of experiment.
Now let's go ahead and scrunch other horizons and see what happens. Okay, select. Scrunch. Okay, let's zoom in and I'll move over for you. Huh. Look at that curve. Are you going to say that was the camera being tilted? Is that lens distortion? I don't think so. Pretty sure that's the atmosphere. Ooh, here's a nice pretty one, taken from above the clouds. Select. Scrunch. And does that look like it proves that the Earth is a globe? No, it just proves clouds are uneven. Let's try this one. It looks like it was taken from a plane, and a lot of people claim to see curvature from planes. Select. Scrunch. Where's the curvature? Ah, I love this one. All right. Select. Scrunch. Whoa! Look at that. Okay, well, the camera probably wasn't perfectly level on that one. I can see that, but it still looks pretty flat. Alright, so we can fully acknowledge that we can sometimes see curvature on the horizon. But does that mean the Earth is a globe? No. Other things can most certainly cause the horizon to appear curved. Curvature does not equal globe. And because horizons still generally appear flat, our hypothesis still stands. But now it has additional fortification because of our further observations. In other words, our hypothesis has withstood this test.
No, it did not in any shape or form. In the end here, you used low-resolution images and you have the same problem as before. And you cherry-picked this evidence. I think I was fair to you. I've shown most of these two videos, and I think I have covered all your important points. Now I will show two globe proofs made by flat earthers. This is a quick one, but Kyle, if you see this, please explain these two examples. Let's start with the Scottish flat earther Flatza. He have made a lot of videos from this place. Here he's filming the lighthouse on Bass Rock on the Scottish coast. Okay, we stopped the video here. Here you see the lighthouse on Bass Rock. Let's compare it with the image taken on a closer distance. Kyle, why is the bottom of the island missing in the video from Flatza? Where is it? In every video he's taken from this location, a lot of the island are missing. Why is this? It can't be atmospheric conditions, because he have taken videos from this location time after time and always the same result. The bottom of the island is missing. Explain that, please. And here, Kyle, you have a classic boats going over the horizon and disappear with the bottom first. This is from Harry, a flat earther in Sydney, Australia. I live on an island in the North Atlantic and I see these all the time, ships disappearing over the horizon with the bottom first. Kyle, please explain how this would work on a flat Earth, because it's not atmospheric conditions, because this is always happening in the wintertime, when it's dry, when it's a lot of moisture in the air. So please explain this. Okay, this was all for this time. I will come back later in other videos and follow up on this one and have a look at more of Kyle's upcoming videos. I hope you enjoyed the video. It did get a bit long, but I thought it would be most honest if I showed as much as possible of Kyle's video when I debunked it. Okay, see you next time.